Okay, so at this point, you have supposedly already taken some notes using your book for chapter 22.1, and those notes have covered the beginnings of what we're going to be learning about organic molecules, and that is hydrocarbons. Now, hydrocarbons are two parts to this word: hydro for hydrogen, carbon for carbon. Molecules that are only made of hydrogen and carbon. And these can come in many different forms. The first form that this book is talking about is an alkane. Now, what I want you guys to do is associate ALK, that prefix, with hydrocarbon. So an alkane is a hydrocarbon because of the ALK. Then the last piece here means all single bonds. If you remember back in chapter 8, we were learning about covalent bonds, and carbon, because it only has 4 valence electrons, must make 4 bonds. Well, in an alkane, all it has is single bonds, so it's going to have 4 single bonds. Other possibilities for carbon would be double bonds, triple bonds, in combination with single bonds, always equaling 4 bonds. In the book, we also have seen a difference between straight chain alkanes and branch chain alkanes, which we will be taking some class notes on here in just a minute. Straight chain, the meaning of straight chain isn't that the entire molecule is straight, but that the carbons all are connected in a row, in a line. Okay? The molecule itself might not look linear, but it is going to have you could put your pencil down and trace it through every carbon in the molecule without ever lifting your pencil up or reversing back on your own line. Branched, on the other hand, is going to have carbons coming off in different directions. So if I've got 3 carbon atoms in a row, but then over here there's a carbon coming off of that middle one, that's a branch chain alkane. Okay? And we have various structural formulas for these things. So if I wanted to draw a complete structural formula for butane, which has 4 carbons, I would have to draw every single atom. Not just the 4 carbons, but remember, carbon has 4 bonds. So every single bond that is missing from this picture would be drawn. So they all have 4 bonds, but they can't be bonded to nothing. So that's where we get our hydro part of a hydrocarbon. You would draw a hydrogen for every single bond to fill up those 4 bonds for our carbon atoms. So for butane, that wasn't that bad. It could get annoying doing that over and over again. But when we get to things like decane, nonane, octane, when we get into those higher numbers of carbons, drawing every single carbon and every single hydrogen could be frustrating as a high school chemistry student. So we're going to go into a couple of other options for you. You can always draw this way. Okay, our other options, the book names some condensed options. So what we would do for one of those condensed options is to take those hydrogens. They're all attached to the same carbon, so we're going to write them with that carbon. So CH3. And then this one is a CH2, so that's bonded to CH2. And then another CH2. And then a final CH3. And this bond right here is not between this hydrogen and this carbon, but it is between this carbon and this carbon. The hydrogens are bonded to the carbon they're written with. Okay, you can do the same thing without the dashes. That's also a condensed formula. Or when you have a repeating unit in the middle like this one, you can do something that looks like this, with or without the dash. Put that CH2 in parentheses, and then a subscript telling me how many there are. Okay. Those are usually not formulas that students choose to draw. Instead, students will choose to either draw a carbon skeleton, which I've never seen this outside of our textbook, but it's perfectly acceptable for me, or a line angle structure. The book calls it a line angle structure. I've always referred to it just as a skeleton structure, so straight skeleton. And the way that a skeleton structure works is when you put your pencil down, that is the first carbon. Okay, then you're going to draw angles. Every time you change direction, that's another carbon. So 1, 2, 3, 4. 1, 2, 3, 4 carbons in this structure. So this structure right here represents the exact same molecule as this structure right here. Okay, you get to choose the structures that you draw, but you do need to be able to recognize all of these types of drawings, and you need to be able to tell me how many hydrogens are in the structure no matter how it is drawn. So if we have a carbon skeleton like this one, you have to know that there are 3 hydrogens filling up this carbon's bonds, 1 hydrogen here, 3 hydrogens here, and 3 hydrogens around this carbon at the top. Add those all up, 3, 6, 9, 10 hydrogens with that molecule. Okay, now we're going to do some class notes on naming branch chain alkanes. So get your notes packet ready. While you're doing that, I'm just going to quickly go over the prefixes that were in this chapter. So we are going to need you to memorize the first 10 prefixes for naming organic molecules. So 1 is meth. Okay, methane has 1 carbon. 2 is eth. 3 is prop. So propane might be something you've heard of before. 4 is bute. Butane might be something you've heard of before. Okay, so again, meth, eth, prop, bute, those are prefixes. They have to have an ending with them, like ane if they're an alkane. Okay, after that we get into our geometry, our geometry prefixes here. So pent for 5. Okay, hex for 6. Hept for 7. Oct for 8. Non for 9. And dec for 10. The first 4 are really the weird ones. So if you already have your geometry down for these bottom ones, the first 4 are weird. And one of the things that I've done is I've come up with a little mnemonic device. Mary eats peanut butter, in order to help me remember those 4. Mary eats peanut butter. Okay, let me give myself some more room here, and we're going to take notes in the notes packet where it says naming branched chain alkanes. We're going to have 3 steps, and then we're going to do an example together. So you can divide your note space accordingly. The first step in naming branched chain alkanes, is to find the longest chain of carbon. Find the longest chain of carbon. Find the longest chain of carbon. And if you remember from your notes, the longest continuous carbon chain is called the parent chain. Parent chain. Okay. So, second step, number the parent chain. Number the parent chain, so the branch is attached to the lowest possible number. So the branch is attached to the lowest possible number. And this will make more sense when we do an example. Number 3, name, and we're going to list in order here, name the branch location, branch name, and parent name. Okay, now we're going to do an example. So I'm going to erase my board here and draw out an example, and we will name it using those 3 rules. So keep those rules handy. I'm going to try and give myself room over here so I don't have to erase those rules. Okay, here we go. We're going to go hydrogen and then 4 carbons in a row. So I'm going to do a complete structure here, and then a hydrogen on the end. And then coming down from this carbon, going to have 2 carbons in a row. Add in all of those hydrogens. That one kind of got squished in there, but it works. Okay, so this is our example molecule. And remember, our first step, going back to our steps up here, the first step is to find the longest chain of carbon. Okay, so I'm going to give you a second. Try and find that longest chain. Longest continuous chain. Most students, the first time that I go through this, are going to say, well, the longest chain is 4 carbons. Look, 4 carbons in a row, that's the longest chain. Okay, this way's only 3. But you have to think 3-dimensionally here. If I can put my pencil down and keep drawing, that's still the same chain. So even though it bent in space, okay, it is the same continuous chain of carbon. So really, 1, 2, 3, 4, 5 is my longest chain. Okay, so this piece from here to here is my parent. That makes this part the branch. It is branching off of my long parent chain here. Okay, now we're going to number that parent chain so the branch is attached to the lowest possible number. So what I mean by that is we don't care about hydrogens because we could have drawn this without the hydrogens. The carbons are the important part of this molecule. So if I number this over and then down, 1, 2, 3, 4, 5, my branch is attached to the 3rd carbon. If I number it up and over, 1, 2, 3, 4, 5, it is still attached to the 3rd carbon. So in this instance, it does not matter which way I decide to name this molecule. So number this molecule. 1, 2, 3, 4, 5. Okay, so I'm just going to pick one, it doesn't matter. Then we name it. First, branch location. Well, what carbon number is the branch attached to? It's attached to the 3rd carbon. So 3 is my branch location. Second is the name of the branch. Okay, and this branch only has 1 carbon. Well, what's the prefix for 1 carbon? I already erased it over here, but 1 is meth. Well, meth is definitely going to be part of this branch name because meth means 1 carbon, and that's how many carbons are in the branch. Now, this branch is a hydrocarbon, and we talked about how hydrocarbon is alk, but because it's not its own hydrocarbon, it's called an alkyl group. Alkyl. ALKYL, which I did list over here and I forgot to talk about it earlier. So again, ALK, that's hydrocarbon. YL is going to mean a branch. So this means hydrocarbon, okay, but this piece, YL, means it's a branch. It has taken the place of a hydrogen somewhere on the molecule. So instead of a hydrogen filling up this carbon's bonds, we have a branch, and that's an alkyl group. It's a substituent, a type of substituent. Okay? But because that YL means branch, when we name our branch, it's going to have that YL on the end. So 3-methyl. But we're not done because now we have to name the parent. So 5 carbons, all single bonds. Okay, well, 5 carbons is pent. And then, let's flip back over to this side. All single bonds is ANE. So pentane. ANE. And we will get to molecules that don't have all single bonds, but right now that's where we are. So 3-methyl pentane is our final name for this molecule right here. Now let's continue with duplicate branches. So in the same notes box in your packet, we've got a section for duplicate branches. If you have more than one branch, the name becomes a little bit more complicated. And when you have duplicate branches, the system is a little bit different. So here's what we're going to do. We are going to name all branches. Name all branches alphabetical order. Okay, so you're looking at those prefixes, meth, F, prop, but. That is the piece that matters when you do alphabetical order. So that prefix. We might add another prefix to the prefix. That part doesn't matter. Alphabetical order by prefix. Okay, carbon prefix. Okay, name all branches. Alphabetical order. If there are repeat branch types, use di, tri, tetra to tell how many branches. Okay, so we're going to stop in our class with tetra, okay, but if you have 4 methyl branches, instead of saying methyl, 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 listing it 4 times, we're going to be able to use tetra instead, okay? So here we're going to do an example. I'll draw out a molecule. Okay, I'm going to just use a carbon skeleton for this because it is a lot longer than the last one. So we're going to have 7 carbons in a row. Okay, and then coming down from this carbon, we have 2 carbons in a row. This one, I'm going to stick 1 carbon up, and then this one, I'm going to stick 2 carbons down. So 7 across, and then we got 2 down, 1 up, 2 down, starting from that second carbon in. Okay, so same steps as before. We still need to first find the longest chain of carbon. Okay, so take a second. What is the longest chain of carbon in this molecule? So if you said 7, again, we need to make sure that we think in multiple dimensions here, and we can round the corner without lifting our pencil, so that the longest chain is actually 8 carbons. If we start here and we work our way across and then come down, this is 8 carbons long, so it is the longest chain. That turns everything else here, here, and here into branches. Okay, so parent chain, I've drawn a line next to, and then I circled my 3 branches. Well, before we even start trying to put the name together, let's talk about what these branches are called. So this one has 1 carbon, which we talked about in the previous example. Meth means 1 carbon, and then YL means it's a single carbon branch. Well, so is this one. This one is also methyl. Okay, but this one has 2 carbons, which if you look back at your prefixes, the second prefix is F and YL again because it's a branch. So we have a methyl, we have a methyl, we have an ethyl. Okay, and the names are going to be a little bit wordy, but instead of saying methyl, methyl, ethyl, having 3, we can condense this. Okay, if we have multiple branches of the same type, we can use dimethyl to say we have 2 methyl branches. But we're not quite there yet. First, number the parent chain is our second step of the naming process. So if we take a look at this, if I number from the side and then down, 1, 2, 3, 4, 5, 6, 7, 8, my branches are at 4, 5, and 6. But if I number the opposite direction, 1, 2, 3, 4, 5, 6, 7, 8, 3, 4, and 5 are lower, and that is the correct method for numbering. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now we've got branches. So we've got a 3-methyl, and we have a 4-methyl, and we have a 5-ethyl. Okay. Well, alphabetical order is our first priority. So 5-ethyl is going to come first, and it's the only ethyl, so we're going to start with that. 5-ethyl. By the way, we put dashes between numbers and letters. Okay. we put commas between numbers and numbers, so I was a little bit early on my comma there. So 5-ethyl, and then we're going to have a dash because now I'm going to give the location to my methyl branches. Well, I have methyl branches at 3 and 4, so I'm going to put 3, 4 to show both locations, and then I'm going to say dimethyl, meaning at each of those locations I have a methyl branch because there are 2 methyl branches in this molecule. And then the final thing to name is the parent chain. So 8 carbons long, all single bonds, is octane. 8 carbons, single bonds. Okay, 5-ethyl, 3,4-dimethyl octane.